So, let's continue talking about parametric equations. Parametric equations are equations that use a parameter. Now we might need to find the derivative of a parametric equation, or we might need to find the second derivative. Let's consider a nice example. If y is equal to 6 sine 2t plus 7 and x is equal to 3t plus 1, can we find the derivative of y with respect to x? So, question 1, find dy by dx. And question 2, find d squared y by dx squared. I'm going to do these quite similarly. So, here we go. To find this one, we must find dy by dt, we must find dx by dt, and then ultimately we find dy by dx, which is dy by dt divided by dx by dt. This is how I like to write it. I feel it's a nice way to do it. Now let's see if we can make something make sense here. Let's go. So, what is dy by dt? Dy by dt, the derivative of sine is equal to cosine, so we have 6 cosine 2t plus 7 times 2, so that is 12 cosine 2t plus 7. The derivative of 3t plus 1 is 3. So the derivative altogether is 12 cosine 2t plus 7 over 3, which is nice and simplifies to 4 cosine 2t plus 7. Now, for this second derivative, I don't want you to freak out, because this is how I like to do it. I like to work out dy by dx by dt. Then I like to work out dx by dt. Then ultimately d squared y over dx squared, which to me I like to write as dy by dx, dy by dx by dt all over dx by dt. And if you can sort of see, there's a parallel between what I've done for dy by dx and what I've done here. I'm going to differentiate with respect to t, the derivative. Let's have a go. So, what is dy by dx? Dy by dx is 4 cos 2t plus 7. So the derivative of 4 cos 2t plus 7 is cos differentiates to negative sign, and I have to multiply by 2. So I get negative 8 sine 2t plus 7. And dy by dx, dx by dt, which we've done, is still 3. So now I have everything I need to write my derivative, which is just negative 8 sine 2t plus 7 divided by 3. And that is how we do the second derivative using parametric equations. I think it's really important to note the notation is very different here to what you see on your formula sheet. The formula sheet has dy by dx written as dy by dt times dt by dx. But timesing is the same as multiplying, or dividing is the same as multiplying by the reciprocal. So this and this are the same thing, in fact. And then your formula sheet has d squared y divided by dx squared is written as d by dt of dy by dx multiplied by dt over dx. Once again, dividing is the same as multiplying by the reciprocal. And so once again, they are actually one and the same. The only difference is I don't like to set up these equations and work out the reciprocals. I like to use fractions. There's more examples we could do, but for now, I think this is as good as it's going to be, right? Now, the question is, how do I make this harder? And the real answer is the fact that this question simplified and didn't have a quotient made it easier. If this did have a quotient, then I would need to do the quotient rule in the differentiation. I will now suggest you try that at home, and then if you have any questions, post a comment in the chat. Thank you.